Good afternoon. This is Mike LaFleche with Cap Inc., the product manager for SolidWorks Electrical. And today we're going to discuss how to use SolidWorks Electrical to help you with your cable design, especially with connecting devices, whether those be PCB type devices or standard connectors, standard MIL type 38999 style connectors in this case. So thank you for joining me today. Let me just kind of set the table here a little bit because I know a lot of you are new to SolidWorks Electrical. I see a good number of people attending on this beautiful snowy day out there, so it's a good day for a webcast, right? So what I'd like to do is kind of give you an understanding of what SolidWorks Electrical is based on some issues that SolidWorks and Cap Inc. has uncovered in interviewing our customers. Propose the new SolidWorks Electrical solution here for you and definitely demonstrate how you'd use it for cable and connector design. Talk about some people that have actually started using this product. We have many customers here in New England now have purchased and are using SolidWorks Electrical. And I'll just discuss how people get started using the product. So this is a common thing that comes up in conversations with our customers about electromechanical design. Is what are the ingredients? What are these balls in the funnel here that you see on the screen? Well, those balls in the funnel are some of the ingredients, essentially, of what I consider electromechanical design. You have PCB control type components, and those are typically designed in PCB applications that are really great at doing what they do. Altium Designer and pads, Mentor Graphics pads and Expedition, OrCAD, and there's many other tools out there, Eagle, for example. But these tools, SolidWorks isn't trying to replace those tools. We work very well with those tools right now. We have an application that's part of SolidWorks Premium called CircuitWorks. And what CircuitWorks does is it will let you interchange between the 3D CAD model and the PCB design system. So you can actually send changes back and forth. We actually have a class that teaches how to use CircuitWorks quite well. It's a new class that we're offering at Cap Inc., and we have it up on the schedule several times a year in each of our offices around New England. So definitely keep an eye out for that if you want to learn how to use CircuitWorks. On the other hand, we have the actual system level design. Not the microscopic level design of a circuit board, but the macro scale of a system itself, like this bottling machine that you see right here with lots of different systems interconnected. That's where SolidWorks Electrical will play very well. And a lot of people are using AutoCAD to do this right now. Some people are using, they'll use AutoCAD for doing like the schematics, the detailed schematics, and then they'll use Visio for doing more of the block diagram, high-level connection stuff. But the problem with these systems is that they're not connected to each other. They're certainly not connected to the 3D model in SolidWorks, and they're a little bit more difficult to use than people would like. Some people even kind of go out on a string and a prayer and create their first prototype machine, measure out all the wire using string, get the multimeter out and make sure everything's connected the right way, and then save it in Excel. So what I'd like to do is just kind of have you guys answer a quick question for me. How do you guys document schematics or wires and cables today? The topic of the webcast is wires and cables, but think of this as all of the electrical design that you might do. So thanks for participating in that poll. Looks like a bunch of people are voting right now. We're at about 75% voting. And we're almost at 100%. Close that poll in just a second and share those results with you. All right, I'll share those results here so you can see what the results were. So, almost half of you on the webcast use some kind of 2D drafting tool or AutoCAD maybe draft site from SolidWorks, of course. But to do quick 2D designs, a lot of people have Visio. That number is pretty much in line with what I've been seeing out there. Of course, SolidWorks has the SolidWorks routing tool for routing electrical wires, and that's a fantastic application, but it still doesn't automate as much as we would have hoped. That's what SolidWorks Electrical is all about. It works very well with SolidWorks routing. And Excel. People create from to lists in Excel that say this component is connected to that component. And finally, we still get a lot of people using a string on a prayer. So thanks for participating in that poll. So let me fast forward just a little bit here. SolidWorks Electrical is a design application that unites the mechanical and electrical world in a way that's never really been done before. First of all, we're introducing a 2D standalone CAD application called SolidWorks Electrical. So SolidWorks Electrical on the left-hand side here with the schematic and all the people in front of it. This is an application that you can use. You don't necessarily need to have SolidWorks mechanical software on the machine. But it's an application that replaces using something like Visio or AutoCAD to describe your designs, whether it be top-level system design, cable and harness design, pin diagrams, and all those things. So this is a standalone CAD package, but it also connects to the 3D model in SolidWorks Electrical 3D. So this would be a plugin on the right-hand side for SolidWorks that will take the information created in the 2D SolidWorks Electrical application and automatically connect to that schematic. So in this case, you can create that control panel layout. You can do many more things than control panels, but most equipment has a control panel. That's why I use this picture. So what I'll do is show you, what the result of using SolidWorks Electrical 3D is. So here on my screen is SolidWorks, and I have SolidWorks Electrical 3D loaded, which automatically forms a connection to a schematic. And in this case, you can see we have lots of components, right? We have wires and buttons that were on the front of the box connected to a wire harness. We have a circuit board, which was created in pads, Mentor Graphics pads, and then brought in through SolidWorks. We also have connectors that connect to that circuit board. So we're not designing the circuit board with SolidWorks Electrical. We're just importing it and connecting to it with this maybe this Wago connector here. And of course, we have some more headers here on this circuit board connecting that, connecting wires to a switch, and these Pabst fans that you see in here. Once you have one of these wire harnesses, you can open them up. Well, let's not open up the clip. That's a little boring. You can open up the wire harness itself and actually flatten that out. So if I open that, you'll actually see the wire harness all by itself, and then look at the flattened form board representation of it. And these are tools that if you're used to SolidWorks routing, you can do this already with SolidWorks routing, but it takes a lot of effort and work to do this. Whereas in SolidWorks Electrical, the information that's already done in the schematic can be used to create the wire in 3D. So let's start with something just a bit more simple. We'll go to the 2D side of things first and create a cable. And we'll use the SolidWorks Electrical 2D application. We'll close that out. Alright, so let's go to SolidWorks Electrical 2D. And you can see it's a separate application here at the bottom of my screen. And by the way, if you have any questions during the webcast, this is a live webcast, use the questions panel on the right-hand side of your page. Of course, I'll leave some time at the end for for questions as well. So this is SolidWorks Electrical 2D, and I have a workbook open for creating a MIL standard cable. I have a cover page. I have a line diagram, a pin diagram, and a form board. And this is just an empty project right here that I've just opened. Let's show you the end result of one. I have one on my desktop as a PDF file. So here's a final result of a cable with 2 MIL standard connectors and a USB connector. And you can see that on the first page is just a pictorial diagram, of course, generated in SolidWorks. On the second page, I have a single line diagram showing that I've connected this component that I've labeled P1, and I'll zoom in on that just a little bit so you can see a little bit easier. It's an amphenol connector connecting to P3 using this cable W1. I'm also using the same cable to connect P1 to P2, the Samtech USB connector. Now, if I zoom out just a little bit, I'm going to go to page 3. And if you look at page 3, this is a multi-line diagram showing the pin locations and the description of the pins. And even a from-to list with the wire number, and I'll get to the wire length in a little bit. That's what we'll get from SolidWorks. But you can see that same cable, W1, is being used here with the colors and the numbers of the wires here as well. And this was also generated using SolidWorks Electrical 2D as well. And then I copied my 3D to the flattened form board drawing. So how do you create something like this? This is usually a lot of work in 2D applications like AutoCAD or Visio. It's not that much work in SolidWorks Electrical. So I'm going to close this project and go to the Projects Manager. What you have here is a project-driven system. It's managed by a SQL database, and that's what enables the 2D and the 3D to work with one another. And I want to go ahead and create a new project, and you create a project from templates. So in this case, I'll choose a MIL standard template, but you can see we have all the international standards here, and these are the ones that are coming pre-baked with the software. So I'll choose a MIL standard cable project, and I'll give it a name here. I'll call it today's electrical webcast. And this is information, metadata about the project right here, and that's what will show up in the title block, for example. And I'm going to make this a 38999 style connector description here. And that will now show up as a project in this list here that you can use. And it should open it up for me. And it shows me a document tree with a binder with 4 documents. And these are documents that I like to use every time I create a cable drawing. A cover page, a line diagram, a pin diagram, and the form board drawing. So let's go to my line diagram page. And you can see all my information has been filled out here. And I'm going to go ahead and insert some objects. So you notice the interface here is a standard kind of command manager type interface. And depending on which page you're on, you might see different types of commands. In this case, I want to insert a symbol from a library. And you'll notice that it brings up my last symbol used, but I can go to the other symbol button here and choose from my symbol library different types of connectors, drives, and these are really symbols that are pictorial in nature on a line diagram. You can also use just black box type symbols. I just wrote a blog article on blog.capping.com about black box symbols as well. But in this case, I have the connector that I'm looking for, this TV06T9 connector. And I can drop that anywhere on this page. Now what it asks me for, and this is pretty cool, it's asking me for a mark number. It's telling me that this is going to be component P1. And I can also establish a manufacturer for that particular component. You can get that type of connector from a myriad of different suppliers. So let's go ahead and choose from our database, which manufacturer should have that we want to use from. In this case, I'll choose an Amphenol connector from the manufacturer's database, and I'll choose one with 9 pins on it. You'll notice it actually shows me all of the circuits that belong to that component and what each one of those pins do. So that's all built into the database. So I'll use that, and it actually gives me some metadata right on that symbol showing me that. Now I'll go ahead and insert another symbol, and I'll browse to my connector library here, and I'll choose the USB connectors. And I'll drop a USB connector over here, and it automatically labels it P2. Now I'll choose from my manufacturer database, Samtech is the manufacturer. And there are the connection information right there. So I have 2 different components right now. Now let's go ahead and go for the gusto and add another. Now let's add it another way. Rather than searching through the symbol database, I can go to my symbol tab here and actually browse through, very much like Visio, through different components. So I can go to loading devices, supply type devices, and I have a MIL standard connector area. I'll put in this connector right here. I'll plop that right there. I'll choose from the database, keep it easy, stick with Amphenol right now, and choose that component. There we are. So we got 3 different connectors on our page here. How do we connect them? Well, we need to draw a cable to connect these components. So here's the draw cable function. And I can just pick a different representation for a cable. The wires that go into the cable really matter. But in this case, the representation of the cable is pretty easy. Just pick a color that you want and connect the items together. So simply by drawing that line, it knows that it's connecting P1 to P2. If I double-click this line or cable, it's showing me that it's connecting P1 to P2, and it's showing the pin data that belong to each one of the manufacturer components. So just like that. Let's draw another cable. It's actually going to end up being the same cable in the end, but I'm going to connect P1 to P3 as well. So let's call out some wires that should go into this cable. So I'll go in and say reserve cables and cores by right-clicking on that cable. And it's showing me the name of my project and any cables that are in here. Right now there are none. So I'm going to say I want a new cable. And I can go into my cable database, which for each standard has thousands of cables. As you can see, for the AWG standard we have 6,000 plus cables. But I know I want a 22 gauge wire in this cable here. So I'm going to choose from the drop-down list the 22 gauge wires. And now I have 336 elements in the database. Maybe I want to choose a certain number of conductors in that cable. And I'll choose 12. So now I'm filtering down, and I can see LAP is the only manufacturer in my database that has that in here. And I can go into the properties of this cable and see all about it. See the wires that are in that cable. So imagine all of the information that comes with the system. This is out-of-the-box information here. And it's showing me all of the wires that cable uses. And these are from the manufacturers. You can certainly add your own as well. It's very easy to add your own. So I'll use this one right here. I'll add it to the used list here. And now it's showing me that I have cable called W1, and then these are the wires that would be available in that cable. And I want to use the first 4 wires in that cable for that piece of the wire right here. I'll do the same thing here. I'll do detailed or reserved cabling. Go back into here and pick maybe the last 4 wires that go in here. You can certainly clean these things up. It gives you a little label here for the cable. And now I can get into more detail. I can double click this cable and see that I have the circuits on each of the parts, P1 and P2. I also have the cable. And I'm going to say I want these to connect to this cable right here. I'll choose these right here and connect those. Just highlight them and drag and drop, and it's very easy to connect. Much easier than in real life. No crimping or anything like that. Alright, so that looks good. I'll close that out. I'll do the same thing for the other one. I'll choose the last 4 right here. So I have 5, but that's alright. We won't use the final pin. And you can see as you click each one, it's showing us the what they're related to. Now, all this information is available. I can actually insert a connection label for each one of these components. So maybe on P1, actually, let me choose a connection label that has at least 9 rows. I'll choose 10 here. And I'm going to say I want this to go with P1. So you can see these are the components that have been created so far, P1 through P3. I'm going to say associate that cable or that table with component P1, which is the Amphenol TV06T9 component. And you can see what it's done so far. The cable is in here, the cable cores, all that information from to is set, origin, destination. Excellent. Maybe on the other pages we'll show the tables for P2 and P3. So that looks good. Let's go to SolidWorks now. Let's tell the system to generate a 3D model of this. So that's all I did. Just hit one button to create the 3D model, which then shows up in my document panel. And I can renumber these things if I want it to go. I like to have all my documents start at 00 and jump by an increment of 10. So now I have 0, 10, 20, 30, 40, which updates all of my sheets wherever they may be used. And now I'll open in SolidWorks that blank assembly, essentially. Now, what I want to do is insert the components that were called out in the schematic. And what SolidWorks Electrical does in 3D is it gives us the location in which we've created our components and the same exact components. Isn't that pretty cool? Those are the same exact components I had on the schematic. And I can insert P1. And you see it's bringing me the 3D representation of that component. And I'll just drop it in here. Now, if I didn't like where it was placed, I could use the rotate command in SolidWorks. Move with triad is the best way, I think. It's very easy to move things around in that mode. So if I look at this from the front, you right-click on it and say move with triad. I can pick the triad symbol here and rotate it around maybe 180 degrees. I can snap it right on to that increment. So that looks good. I'm going to turn off my origin symbol there. So that's my first component. And I can unclick this or check this thing right here, and it's going to show me what I have left for work. All I have to do is place P2 and P3. By the way, all of this does not have to be done on the same computer. It's just you need a connection to the database. And that's all you would need to do. So there's the P2 component right here. And I can move that wherever I wish. I guess that looks pretty good for now. Maybe I'll rotate it like so. Now I'll insert P3. Maybe something like that. It's up there on that elevation. And of course, I'd be referencing other assemblies, so that this would be mating with other components. So there's my 3 components. Now, all I have to do is route the cable. So with one click of a button in SolidWorks Electrical 3D, I can now tell SolidWorks to route cables connecting each one of the wires that belong in those cables to those components, simply by drawing a quick 2D schematic. Not even a real schematic, a pictorial diagram of the schematic, which anybody can do. And there it is. Got the color of the wire already baked right in there because that was called out on the schematic. It's got the pin locations on each one of the parts. If I were to look at the inside of the Samtec USB cable here and make it transparent or something, you can see, let me turn off the black edges there, you can see where the wires are actually going to each one of the terminal points here. And those are just set in the 3D part. Let me make that solid again. There's my cables going up to the other MIL standard 38999 connector. Now, if you really wanted this to actually route a different way, you can actually give it some assistance using 3D sketching technology. I can say, create a routing path, and it will give me a 3D sketch that I can start using, and I can now say, I want my wires to, kind of do something like this. It might be an object in the way where I'm going around it. That looks good to me. So now if I tell it to route the cables again, I'll tell it to delete the existing route, and it's going to reroute using that path as a helper, so the cable and wire will magnetically attract itself to that 3D sketch. So you can think of this as Conduit, or just making sure you're routing around areas that might have some interference, EMI and stuff like that. You just want to get that cable away from a motor, for example. But with SolidWorks Electrical, that's very easy because it will respect the wishes of this 3D path sketch that I've placed in here. As much as possible. You can see it actually moved it over a little bit over here. So it would route, rather than directly to it, it'll route around the corner. It was actually looking at the minimum bend radius of the wire and cable, so it's respecting that as well. So it's looking at those 2 items. So once you have this, let me just take a quick picture of this. In SolidWorks, you can just do a save as a bitmap image or a JPEG image, right? So I'll save this as a JPEG on my desktop. And now I will go to my 2D side of things, go to my cover page, and I can insert, we have full drawing tools inside of the system. I can attach an image. Just wanted to rescale this picture that I'm bringing in, but I'll just do it manually after the fact. So I have the picture of the model right here. I'll just drop that onto a page here just to make it look a little nicer here. There we are. So there we are. There's the name. There's our cover page with a nice picture. We have our line diagram showing how everything was connected. So rather than trying to do this with a from-to list with Excel or something like that, it's much easier to do it pictorially. Now, if we notice that the wire length isn't in here yet, so let's get that information in the table by just telling SolidWorks to update the wire and cable length using SolidWorks Electrical. So it's just sending that information, updating the database. And then if you update the system, it will actually, or update that drawing page, I should say. There we are. There's the cable length, stub length, all that information is built right in there. Now, if you want to get more detailed, you can actually get that pin information, to actually create a pin diagram. So I'm going to go to another page inside my schematic. Here's my pin diagram, and I'm going to insert symbols again. But when you have a schematic diagram of a connector, you'd use another symbol. You wouldn't use those pictorial-like type symbols. You might use a single pin like this. You might use a collection of pins with symbols like so. So I'll use this 12-pin option right here, and I'll drop one of those in. But that's going to represent P1. Remember P1, the part that was already in here? The Amphenol TD06. So I'm just associating it with that was already cross-referenced on this page right here. So that's in fact the same P1, just a different representation of it. And then I can insert the same symbol again for P2. You might have a different symbol for a USB, but I'll just use the same one this time. And I can rotate these things around as well. Maybe do something like that. And that's going to be P3. So now all I have to do is just connect the wires up. And you can draw more than one wire at a time with SolidWorks Electrical. So I'm going to say P2 connects to P1. So just like that, I've connected them up. Now I can draw these wires right here. Let me just go back a little bit. Maybe I'll start over here. There we are. That looks good, doesn't it? You can stretch things around to make them look a little cleaner, easier to read. Very easy to use that inside of SolidWorks Electrical. This is stuff that takes a lot longer in other 2D CAD applications. You can number all these wires. You can certainly group them with the same cable cores that you had previously over here. So I could say that is that. You see it actually puts in that it's part of W1, and it's got the black, blue, green, and brown right there. And I'll do the same thing over here. Take these, associate them with those. Now our table data can go in here very quickly. I can insert a connection table here. Now these are kind of big. You might actually use something a bit smaller. I'll show you an example of that, but I'm going to say associate that with P3. And it's showing me all the connection information. Origin, destination, cable W1, all the length, all that information is still coming in. You can also insert them with different labels here, so let me show you that. Maybe one with 6 points in it. So that's just another example showing how the pins are coming in. A little bit smaller profile, but serves the same purpose. This is really easy. I mean, it's much easier. Everything's connected. The data in SolidWorks and the data in 2D SolidWorks Electrical is all connected. Of course, this is only one small example of what you can do with SolidWorks Electrical. If you've seen any of my previous webcasts that are up on our Cap Inc. YouTube channel, you'll see many other examples for using SolidWorks Electrical for doing complete automation equipment, dealing with terminal strips, the same MIL standard connector stuff that we've been talking about, fully documented wire harness documentation. So there's really quite a bit that you can do with SolidWorks Electrical. This replaces systems. Some people use AutoCAD. Some people even use AutoCAD Electrical. This is a tool that would replace AutoCAD Electrical quite well. So let's just kind of review a little bit where we've gone so far. Hopefully you've seen that it's fairly easy to use. The SQL database helps you connect between 2D and 3D. That SQL database, by the way, helps you connect with other systems. For example, you can, this library that's housed in the SQL database right here is in, something that's getting updated all the time. There's 500,000 parts in that database right now. You can add more, of course. You can connect with SolidWorks Enterprise PDM automatically with the system. There's a toolkit built right in to connect to it. There's also a toolkit to help you connect with your manufacturing or MRP or ERP system. So if you have all of your manufacturer parts in there, you can connect to the same database. Multi-language, but we've talked about single-line schematics today. We didn't talk about the symbol creation wizard yet. I'll talk about that just really quickly before we wrap up. We saw the real-time bidirectional link. The reports, I haven't even, I'll show you the reports in the wizards. Right now before we wrap up, since we have a couple minutes left. So how did this all work behind the scenes? Well, in SolidWorks, this part has information in it. If I go in and open that part, you'll notice that it has the pins built in. And this is similar to how you would do it with SolidWorks standard routing, but this connects to the manufacturer's database with the 3D electrical plugin. So if I were to teach this part to be SolidWorks electrical component, you give it some relationship data. So if it was a rail type component in a cabinet, you define the left, top, front, and bottom in the mate references, so they would mate very quickly. And then you get to define your connection points. But you can actually define your connection point by a manufacturer's part in the database. So I can actually go to Amphenol here, do a search for all the Amphenol parts in the system, and select it, and actually say pin 1 is, the male power pin, 1 plus 5 volt DC, 2, 3. So you actually get to define them based on real data. Okay, so that's the really cool part about the system. And of course, the 2D symbols also work that way. If I were to look at the 2D symbol of this Amphenol connector, I can open that symbol, and see that I have these same pins right here, and these pins are connecting to the other same points in the database. So to review, we have SolidWorks Electrical, the 2D aspect of it, which can be bought separately. In fact, we've had several customers that don't have SolidWorks that just have SolidWorks Electrical 2D. The SolidWorks Electrical 3D, of course, requires SolidWorks. So it's just an add-in, and you would just use it as normal. Now, to get started with the system, we recommend taking our classes that we have. We'll help you set up the software, of course. We'll come in and offer to install the software, help you get the database set up. It's not too hard, but getting it set up the right way the first time is important. And then we have a class for the 2D software, which is 2 days, and a class for the 3D software, which is 1 day. Once you're up and going with that, you call up Cap Inc. as normal for your tech support. We have a dedicated resource here at Cap Inc. for SolidWorks Electrical. We've done fairly well with it and have many customers in New England already using it. So I encourage you to reach out to me. You'll have a follow-up email at the end of the webcast, and you'll be able to contact me with any questions. I'd be happy to provide you with a quote for your company to convert your team to using SolidWorks Electrical, and get you set up with when the training classes are happening. By the way, Cap Inc. has just invested in brand new training equipment for all of our offices around New England. We have a mobile learning center as well now, so we can come to you to do training, or you can come to one of our standard offered classes where you can network with other engineers. It usually ends up working quite well. So this has been recorded, so you'll get a link tomorrow with the recording and my contact information. If you have any other questions on it, I would encourage you to reply to that. And I want to really thank you for joining me this afternoon. I want to wish you a Happy New Year. I'll hang around for a couple minutes for any other questions. I see a couple questions that are private that I'll reply to directly at the end of the webcast, but if there are any other questions, feel free to chat now. Otherwise, I want to wish you a Happy New Year, and we'll see you around in 2013.